Looking through some more First Stats 1 revision today, we're going to take a look at the geometric distribution. So this is chapter 3 from the First Stats 1 textbook. Now this is split into two parts. There's the geometric distribution and there's a negative binomial. Now they're both in chapter 3, but for today only, I'm just going to cover part 1 of this as the geometric distribution, and then the next video I'm going to do will be on the negative binomial. So let's jump straight into these questions. I picked a range of questions out. Now these are all from the First Stats 1 textbook, as you can see on the screen here. There isn't any exam papers that have really any questions for this apart from the specimen and the June 2018 and June 2019 papers. So I've stayed away from them, just pick questions from the textbook. So there's a mix of questions. Let's have a look at what we've got. So as you can see above, this is the exercise that it's from, 3A. This is the fourth question. So we've got Bernard. He's passing an examination to get into law school, and he can take the examination as many times as he likes, and the probability of passing on any one attempt is 0.3. So this is a pretty standard question, just looking at a bit of probabilities, and then part B just wants you to state the assumptions that you've used. So let's have a go at doing this. Let's just change the pen colour. I don't want it to be red. There we go. So 4A. So question 4A. We've got to find the probability that he passes on his third attempt. So if he passes on his third attempt, that would just be the probability that x, here we're just going to call it the distribution x. So let's just define this distribution first. So x is geometric distribution with a probability of 0.3. Okay. So that means probability that x is equal to 3. Just he passes it on the third attempt. So the probability that you pass exactly on an event, well, we write this probability as the probability, so it's p, no probability, times 1 minus p to the power of x minus 1. So x minus 1. Okay. So what we can do now is start defining this function here in terms of p. So we know p is 0.3. So 0.3 times 1 minus 0.3 to the power of x minus 1. Now your x here is your x here. So in this case it'll be 3 minus 1 giving me 2. Okay. So if we put all this onto the calculator, we can work this out. If I put all this in onto my calculator, what I'll get is 0.3 times 0.7 squared, which is equal to 0.147. Okay, and that's simply all we've got to do for that one. So 0.147, that's the probability that he passes on his third attempt. The second part, so that was part 1. The second part here, he takes at least 4 attempts to pass. So remember, when we're looking at least, when we see this word at least in probability, it's going to be a probability that are greater than. So this will be the probability that x is greater than or equal to 4, because it's 4 attempts. Now, just like we would with any standard probability question where it's greater than or equal to, this would be 1 minus the probability that x is less than or equal to 3. We want to get rid of everything else underneath. So when you're doing less than or equal to, that's 1 minus bracket 1 minus p to the x. So let's just write this down. So that's 1 minus bracket 1 minus p to the x. So what we're actually doing is 1 minus bracket 1 minus p to the x. So if I just write that out in full, you can see what actually cancels here. So just to show you how this actually works. So it's 1 minus bracket 1 minus p to the x. So let's just double check we've got all that right. So it's 1 minus p to the x. Now, if you do 1 minus, and then you've got 1 minus here, that's 1 minus 1. So that'll just be 0. And then you've got minus lots of 1 minus p to the x. So what we just get left with here is 1 minus p to the x. Okay. We know p is 0.3. So what we can do now is just sub in our values. So this is just going to be 1 minus my p, which is 0.3, to the power of x, which is going to be 3 in this case, because we're doing it less than or equal to 3. So that's going to be 0.7 cubed. And if you put that on your calculator, what you'll get is 0.343. Okay, so that's the probability that it takes at least 4 attempts to pass there. Part B, just finally here, we have to state 2 assumptions that you've used in the model. Now, this is a very standard question with the geometric distribution. If you ever see anything like this, the 2 assumptions straight away, you need to be thinking, that the attempts of passing, or the attempts, are independent of each other. So the attempts are independent of each other. So they're independent of each other. So that's my first point there. And my second point that we make is that the probability of passing remains the same with each attempt. So the probability of passing remains the same. Remains the same. Okay, and that's that question fully done there. So how many marks? That's 7 marks for that. You know, pretty standard question. I'd be quite happy if I got that on my exam. There's nothing too tricky there to catch you out. So that's that question fully done. Let's move on to the next one. Now, this is from mixed exercise 3 here. Question 2. So what we've got here is a percentage of defective welds, which is 10%. So let's write down our distribution first, because that's literally part A. We've just got to state the distribution. It's always a good thing if they don't ask you to do it as part of the questions, do it anyway, because it helps with your working. So question 2A here. So we're checking whether things are defective or not, and we've already been given the percentage of something being a defective weld. So again, we're doing it with x. So x is a geometric distribution here, and our probability this time is 10% or 0.1 if I write that as a decimal there. Okay, so that's my distribution that we can use to model x. Part B, nice easy one. We just got to find the mean and variance of x. So your formula for E mean, that's E of x, the expectation, which we can write as, it's going to be 1 over p. So 1 over p, but p in this case is 0.1, so it's going to be 1 over 0.1, which is 1 over 10, which will be the same as doing 10 times 1 divided by 1, so that'll just be 10. Okay, so really easy. That's how you get your mean there. The variance of x, there's a little bit more work to it, but nothing too tricky, especially with a calculator. So it's going to be 1 minus p divided by p squared. So p is 0.1, so 1 minus 0.1 divided by 0.1 squared. So that's going to be 0.9 divided by 0.1 squared, which is 0.01. And if you do this on your calculator, what you'll get is 90. Okay, or you could do 0.9 times 100, give you your 90 there. Okay, so that's my variance of x. So that's 90. And then finally, we have to find the probability that an engineer, I can't speak, has to check at least 12 welds before finding a defective one. I really can't speak today. So again, we see this word at least here. So at least, we're looking at greater than. Okay, so let's write this down. So C. So the probability that x is greater than or equal to 12, because we're checking at least 12 welds. Remember, this is just the same as doing 1 minus the probability of x being less than or equal to 11. We want to get rid of everything underneath, and then we've got everything above and equal to 12. So this is just the same as doing 1 minus p to the power of x here. Okay, so my p is 0.1, so I've got to do subline. That's 1 minus 0.1. Your x, remember, is this number here. So what probability are we getting rid of here? We're getting rid of it being less than or equal to 11. So my x is 11. So it's going to be 0.9 to the 11. Put this in on your calculator, and what you'll get is 0.314, two three significant figures there. Okay, so hopefully that makes sense. I don't think there's anything, again, too tricky with that. It's just remember, if you see the word at least, think probably that x is greater than or equal to x like we see here. And then when you're doing with a geometric distribution, we do 1 minus 1 less than that if it's equal to it as well. Okay, and this is the formula we have to use. So I'd say a pretty nice question though again. Let's move on to the next one, hopefully a bit trickier this time. So this time now, we've got Olivia playing hoopla, and she continues to throw the hoop until she hits the target. So we've got a random variable x, and the part A asks us to state the suitable distribution. Question 3a, the suitable distribution, so it's x again. It's going to be a geometric distribution, but what's my probability? Well, we're actually not given one. we're just told that she keeps throwing it until she hits the target, basically. So my probability is just going to be P. We don't know what P is. So that's all I can say for that one. We don't have an actual P-value, so that's simply all we can put for that one. That geometric distribution there. Now part B actually tells us that the mean of x is 6. So E of x is equal to 6. But remember, E of x is 1 over P. So therefore 1 over P is equal to 6. Well, we can now actually solve this to work out P. That would be the same as 6P is equal to 1. Just multiplying both sides by P here. So 6P is equal to 1. That's a bit of a wonky one, but that's a 1. So 6P is equal to 1. So now all I've got to do is divide both sides by 6. So P is equal to 1 over 6. Okay? So that's the P, but that's not quite the question. What we actually want now is that the probability that Olivia hits the target first on her 5th attempt. So what that'll be is the probability that x is equal to 5. Okay? So remember, if it's equal to a number, it's going to be P, the probability, times 1 minus P to the power of x minus 1. Okay? Well, P in this question is 1 over 6, so that's going to be 1 over 6. I'm going to put this in bracket now because we're going to times it by another bracket. 1 minus P, so 1 minus 1 over 6, that'll be the same as 6 over 6 minus 1 over 6. So that gives me 5 over 6 there. Okay, so that's 5 over 6 to the power of x minus 1. And remember, the x is what number this is here, so it's going to be 5 minus 1, so that'll be 4 there. Okay, so that's all me working. If you work this out in your calculator, this would be the same as doing 625 divided by 7,776. And if you calculate that, that will be 0.0804. Okay, so that's the probability that Olivia hits the target first on her 5th attempt there. C wants us to find the variance of x. So we've got the mean, let's work out the variance of x now. So the variance of x, well remember, this is the same as doing, or the formula just is 1 minus P over P squared. Okay, well, P is 1 over 6, this is 1 minus 1 over 6 divided by P squared, which is 1 over 6 squared. Okay, do all this on your calculator, but obviously my numerator will be 5 over 6, my denominator will be 1 over 36. Put all this on your calculator, or simplify it by hand, and you'll get 30 there for the variance. Okay, and again, part D, very standard, just state any assumptions. So, use the marks as a guide, 2 marks, 2 points. And the 2 points are just the exact replica of what we said before, but obviously in a slightly different context. So the model here that Olivia's using, what it's assuming is that the throws are independent. So one throw doesn't affect the other. So model assumes throws are independent. Okay, so one throw does not affect the other. And my final point is that the model assumes the probability is the same for each exact throw. So, model assumes the probability, just pick prob, is exact same for each throw. Okay, and that's simply what we've got to say for that one. So if you ever see that part there where it's saying state any assumptions and using a geometric distribution, then we're always your 2 points. Just obviously change it for the context of the question. But like I always say, use the marks as a guide. 2 marks. So 2 marks, 2 points there. Okay, so just to give you a bit of clarity there, I always kind of advise that as a bit of a guide. So let's move on to the next one. 3B, question 7. So Vincent records X, the number of attempts it takes him to parallel park his car in a particular space. So, part A, we just asked to state a suitable probability distribution for X. So, question 7A. So let's write this distribution down. So x, again, it's going to be a geometric distribution. Now obviously it'd be slightly harder on your exam. I'm working through chapter 3, and before chapter, I think it's part 3C, everything's the geometric distribution. So I clearly know it's going to be a geometric. But obviously if you're not given any other information, like a certain number of attempts, it can't be binomial, for example. If it's not per like meter or per hour or something, it can't be Poisson. Just using those little bits of information will tell you that it's a geometric distribution. And we're not given a probability, so again, just like the previous one, we're going to use P. Part B, we're asked to state two assumptions that must be made for this distribution to be appropriate. So I'm getting kind of tired of writing these two assumptions, but we'll do it again. So 2 marks, 2 assumptions again that must be made for this distribution to be appropriate. Well, what that would be that each attempt is independent. So each attempt is independent. And my other point will be that the model, or in this case the distribution, the probability is constant, so the probability remains the same. Probability, I'll just say it's constant. Okay. Part C then. Given that the probability of x equals 2 is 0.16 and that the probability is less than 0.5 or a half, find P. So the probability that Vincent parks correctly on each single attempt. So something slightly different. We've not come across anything just like this yet. So what we're told is that the probability of x equals 2 is 0.16. Okay. Well, we can write this down. The probability that x equals 2, that's the probability P times 1 minus P to the power. Okay. So it'd be 2 minus 1 here. I'm not sure what I was thinking there. 2 minus 1, which obviously would just be 1. Okay. So we just write that as P times 1 minus P. Well, we know that's equal to 0.16. Okay. So I'll just get rid of all that. It's just a power of 1, so we don't need to worry about that. Obviously, if that was 3, that'd be a power of 2 there. So it makes this nice and easy to work with. So P times 1 minus P is equal to 0.16. And we need to work out P. So what we can do now is expand and start simplifying. And hopefully, we might obtain some form of quadratic. So P times 1 is P. P times minus P squared, and this is equal to 0.16. So what I'm going to do is, because this is a negative P squared, I'm going to take everything onto the right hand side. So P squared minus P plus 0.16 is equal to 0. Okay. Now I'm clearly not going to be able to factorise this expression here. Now at this point, it's up to you. You can use your graphical calculator if it has a factorising function on it, and it can factorise expressions like this, or a solve function. But you can either complete the square here or just use the quadratic formula. So I'm going to use the quadratic formula. So what I'm going to say here is that P is going to be equal. So it's going to be, it'd be minus B, so that'd be plus 1 in this case. So 1 plus or minus the square root of minus 1 squared minus 4 times A, which is 1, times C, which is 0.16. Okay, we do all that. And it's divided by 2A, which is 2 times 1, giving me 2 there. We can simplify this now. So this simplifies to 1 plus or minus. Now, I've obviously done all this by hand anyway, but just do it as good practice. So this will be 0.36 divided by 2. And then this square root here will simplify to give me 0.6. So I'm kind of running out of room, so I'm just going to quickly get rid of this bit up here. So just put the eraser on. Get rid of all this here. Okay, so we've got enough room now. So carrying back on up here. So all the way up here now. This can be simplified to be 1 plus or minus 0.6 divided by 2. So this is P equals. Well, this will give you two solutions now. P is equal to 0.2 or P is equal to 0.8, depending on whether you use plus or minus. But we're given a bit more information in the question. P has to be less than 0.5. Well, that instantly rules out this solution here. We can't have that one because it's bigger than 0.5. So therefore, P must be 0.2. So part C here, P is equal to 0.2. Okay, so that's what you've got to do for that one. Bit of a different one there, but hopefully nothing too tricky. The mathematics isn't too tricky behind it. It's just saying the question that we're working up there. But hopefully that makes sense and it's all clear. Let's move on to part D now. So again, I'm going to rub this out. In fact, I'll just erase all of the ink on the slide. So part D, we have to work out the expected number of attempts Vincent takes. Now, the expected number of attempts is just a posh way of saying work out the mean. So E of x, well, E of x, that's 1 over P. And we just worked out P to be 0.2. Okay, so if P is 0.2, this is going to be 1 divided by 0.2, which is the same as 1/5. And that'll be the same as doing 1 times 5. Okay, so my mean, E of x, is 5 there. So the attempted number of attempts is 5. And then part E, finally, we have to work out the variance of x. So remember, the variance of x is going to be 1 minus P all over P squared here. So 1 minus 1/5 divided by 1/5 squared. Okay, put all this on your calculator, and what you'll get here is 20 for the variance of x. So nothing more than just putting, doing a bit of number crunching there on your calculator. So 20 for the variance, and then 5 for my mean. And that's that question fully done. Now I'm going to quickly pause it because I need to go and get my tea out of the oven. Okay, so the good news is my tea didn't burn. So let's finish this question. So we're given this question here. Sujit, I think that's how you pronounce that, is designing a game for a charity day. In his game, the contestants have to roll a fair 10-sided dice a certain number of times. So if the contestant rolls a 10, they win. So he wants the probability of winning to be less than a half. We have to find the maximum number of times Sujit should allow the contestants to roll the dice. So let's get my pen. Let's see if we can solve this. So question 4 from the mixed exercise 3, question 4. So what we do know is that this is a geometric distribution. So x is a geometric distribution. Now my P here, it's not explicitly defined, but we can work it out, right? If it's a fair 10-sided dice, and if it rolls on a 10, my probability just clearly has to be 1 over 10 on 0.1, okay? So that's my probability, my P there. Well, what we're looking for is that the probability, so we're looking for a certain number of times this dice is going to be rolled. So it's going to be x, my variable, being less than or equal to little x. That's the number of times before they win. And now we want this to be less than 0.5. Okay. Well, remember, when we're doing less than or equal to a number, we define this as being 1 minus P. So it'd be 1. So it'd be 1 minus P here to the x, like that. So this is going to be 1 minus P, so 1 minus 0.1, that'll be 0.9 to the x. But we want this to be less than 0.5, so I'm kind of writing a bit slanted, but we want that to be less than 0.5. Okay, well, we can solve this now, right? I'm going to take across now this minus 0.9x to the other side, so it becomes positive. And I'm going to take this 0.5 to this side, so that means 0.5 is less than 0.9 to the power of x. Okay. Well, if 0.5 is less than 0.9 to the x, that's the same as saying 0.9 to the power of x is bigger than 0.5. And I think that's a nice way to work with it. So let's just rewrite that. 0.9 to the x is bigger than 0.5 here. Okay. So now we've got to work out this power of x here. Hopefully this is pretty clear what we're going to have to do. Because we've got this in terms of a power that we don't know, we're going to have to use logarithms. So I'm going to take logs of both sides, and I'm going to bring the x down in front. So this will be x ln 0.9 is greater than ln 0.5. Well, to get x now, all I've got to do is divide by learn 0.9. But be very, very careful. So x, and why I'm saying be very, very careful is because if you divide by a negative number, we have to flip the inequality, and because ln of 0.9 is less than 0, so it's negative, we have to flip the inequality sign. Okay, so just be very, very careful for that. It's a very common occurrence in these types of questions. So x must be less than ln 0.5 divided by ln 0.9. Well, put this on your calculator, what you'll get is that x must be less than 6.579, but we can't say it has to be less than 6.579 times of rolling the dice. We clearly need this to be an integer value, so the next smallest value past this 6.579 will be just the next lowest integer, which will just be 6. So x must be less than 6. Okay, and there we have it. So x must be less than 6. So the maximum number of times to roll the dice is 6. Okay, so there we have it. So that's the final 4 marks there. So I hope this video has helped. Be sure to like, be sure to subscribe, leave any comments, any feedback, all that good stuff. But yeah,